Hello, Heritage Academy Geometry students, and welcome to another riveting edition of Geometry, Seeing, Doing, Understanding. This is lesson 4.4, Congruence Proofs. When it comes to writing proofs, you might be feeling a little bit like Donkey here in this picture. But you know what? This is just something we're going to keep practicing, and it'll get better and better every time. So buckle up, because we're going to get started. So before we go any further, let's talk about ultimate and intermediate objectives. So throughout this chapter of congruency, I kind of wanted to take the idea of congruency and apply it to our Christian life. And Eugene Peterson once said the Christian life is the lifelong practice of attending to the details of congruence, such as congruence between what we do and the way we do it. Congruence between what is written in Scripture and our living out what is written, and congruence of the Word made flesh in Jesus with what is lived in our flesh. So that idea of basically living our lives as the ultimate example of what Christ did in his life and what the Scripture tells us to do, pulling that together with who we are so that we remain congruent in our spiritual life. I just love that idea, and I'm using that as a guiding principle as we study this chapter, and I hope you are too. Now, more specifically, for this lesson, we are going to identify congruent features of a triangle. We're going to use given information to prove congruence in triangles, and we're going to explore different ways to write the same proof, but mostly we'll do that exploration together in class. So as I mentioned, the big focus of this lesson is writing proofs, and in particular, congruence proofs. So we're going to start with this image on the left, and we want to keep in mind two major things when writing this proof today and when writing any proof in geometry. And the first of those two things is we need to be thinking, where should we begin? And usually we can begin with what's called the given information. So for this image, the given information is that CA is perpendicular to AD, CB equals BA, angle C is a right angle, and angle CBE and angle DBA are vertical angles. So in addition to thinking about where should we begin, we also want to keep in mind where should we end. And for this particular figure, where we want to end is by proving that CE equals AD. So keeping in mind the information that's been given to us and keeping in mind where we want to end up or what we're supposed to prove, we're going to use conditional statements to show how the given information proves the conclusion that's been given. So let's just start with our first piece of information that was given, which is CA is perpendicular to AD. So now let's get into this conditional statement using this piece of information. So if CA is perpendicular to AD, then we can also say that angle A is a right angle. But again, remember, we also need to tell the why. So we can say this because perpendicular lines make right angles, which we've learned in a previous lesson. And if we wanted to be mathematical and simplify this even more, we could just say the definition of perpendicular lines. And that's for like if we were writing a real formal two-column proof. So what else can we say? Well, we can actually use that conclusion from that statement to make a hypothesis for a new statement. So if angle A is a right angle, then we can also say that angle A is then equal to angle C. And we can say this because it was given already as a piece of information that angle C is a right angle. And we could also even say that both angles are equal to 90 degrees because all right angles are equal to 90 degrees. That's not something that's necessary for this proof, but it is an extra piece of information to be thinking about. Let's go ahead and mark our right angles, angle A and angle C, with our little boxes before we go any further. Let's keep using conditional statements, but let's move to a different piece of information that we've been given. so that we can keep moving forward. So let's look at if angle CBE and angle DBA are vertical angles, then what can we say about them? Well, we can say that they're equal. Why can we say that they're equal? We can say this because it was given that angle CBE and angle DBA are vertical angles, and we know that vertical angles are always equal. Isn't it amazing at how some of these things we've been studying are just all coming together in this moment? It's fascinating. Now, while we're at it, let's go ahead and add those little curved arc lines to show that those two vertical angles are equal, because sometimes adding that visual piece really helps us to keep track beyond just the words that we're writing. At this point in our proof, we've used quite a bit of the given information, and what we've discovered as we've worked through that information, that two sets of these angles in these two triangles correspond. So we found that angle A corresponds to angle C, and that angle CBE corresponds to angle DBA. And remember that saying that they correspond is just another way to talk about how they're the same. So we want to keep this important information in mind, but we also want to remember that we're ultimately trying to prove that conclusion that CE equals AD. Sometimes at this point in the proof, we can lose track or lose focus of ultimately what we're trying to show here. So it's always good to go back and remind yourself periodically of what that final outcome needs to be. And in this case, it's to prove that CE equals AD. So how can this information help us? Let's find out. At this point in the proof, we want to start combining information that we already have with any other given information that we haven't yet used. So let's go ahead and do that. So if angle A corresponds to angle C and angle CBE corresponds to angle DBA and CB equals BA, which is a piece of information that's been given. And before we go any further, let's add our tick marks in because that gives us a visual. Now think about this. When you look at that image on the left, I hope that something's jumping out at you. And what should be starting to jump out is that we have two angles that correspond to each other in each of these triangles with a side in between those angles that also corresponds to each other. And when that happens, we can say that those two triangles are congruent, and we can say they're congruent because of the angle, side, angle postulate. So now that it's been shown that the two triangles are congruent by the angle, side, angle postulate, we can kind of break this information down a little bit more. So each angle from one triangle will correspond to an angle from the other triangle. And we found this to be true, that if angle A corresponds to angle C and angle CBE corresponds to angle DBA, then we can also say that angle D corresponds to angle E because we've established that these are congruent triangles because of the angle, side, angle postulate. So we can also look at the sides from the triangles, and we can see that those sides correspond as well. So if CB equals BA, and all of those angles that we mentioned before are congruent, then we can say that all the sides are congruent. So BE is going to equal BD, and finally CE is going to equal AD. Whoa. If that seemed like a lot of information to you, just take a deep breath and comfort yourself with knowing that we're going to write so many proofs this year that you're just going to be little proof writing geniuses before this is all over. But I actually want to shift our focus to an important geometry alert. And that alert is that when we're naming objects that are congruent and we're really focusing on this idea of congruency, then we need to name them in a certain order that shows the congruent parts. So here's an example of a correct way to talk about how these two triangles are congruent. It's correct to say that triangle CBE is congruent to triangle ABD because we put all of those angles in the correct order of how they correspond in the figure. It would be incorrect to say that triangle BCE is congruent to triangle ABD, because you can tell from the figure and from our discussions that angle B does not correspond to angle A. So putting both of them first doesn't make any sense. And angle C doesn't correspond to angle B. So putting those angles second doesn't work either. We want to make sure that our order is correct based on congruency. One final note to make here is that there are many ways to write proofs. We have our really standard 2-column proof that you see in our book, where we have statements on the left and reasons on the right. Now, if you wanted to write a paragraph proof, you could use your if-then statements to do that and kind of link those statements together as sentences in a paragraph. If you're more of a visual person, you might like to use a flow chart or even just pictures to show proofs. So we're going to explore all of these types of proof writing in the months to come. But ideally, keep in mind that your proofs need to have given statements combined with other statements, and we draw some kind of a conclusion from those statements.